Okay, Cup, welcome to the 11th class of Big Data Analytics. As you can see from the class schedule here, let me share I'm still sharing the screen, correct? Yeah. Okay, as you can see from the class schedule, the timeline here, we kind of spend the first third in the foundation that you would need. So, reviewing a little bit of mathematics as well. And linear algebra and whatnot, calculus, a little bit of that. And then we spend the middle part on the basic, the simple unsupervised learning and supervised learning techniques that you would likely use for your data analytics project. And so the last third is really about, a project workshop. So it's going to give you more of a hands-on feel to your learning process. Okay. Again, if you recall, the three major paradigm, the principal paradigm of machine learnings are unsupervised learning, supervised learning, and reinforcement learning. Okay. For data analytics, chances are you would be using unsupervised and supervised learning. There's a lot less application in data analytics or in analysis of data that requires reinforcement learning paradigm. Okay, so your tools would be what we introduced in the middle part, which is unsupervised learning. Okay, like clustering analysis, dimensionality reduction, whatnot. Supervised learning, again, top level, you're talking about prediction or regression problem or classification problem. In terms of tools, I separate into two families, sort of like a neural network based type learning and versus decision tree type learning. Okay, so decision tree, random forest, this would be like, say, sort of a tree-based family, and multi-layer perceptron, and maybe later on convolutional neural network, LSTM. These are kind of neural network based tools. Okay, and of course, another two set of tools that you would be using are the visualization and statistical tools, statistical method that you learned in your previous year. Okay, so we had a review, but we didn't really explore that much into probability and statistics. But yes, it is possible for you for this class project, to actually not even use any kind of machine learning tools whatsoever. Okay, you can do like visualization, you can do traditional statistical method as your primary tools, if that's what your data supports, or if that's what's appropriate for your data. Okay, so we might have time to have a little bit of discussion about what's a sure sign that you should be using classical statistics versus what's a sure sign that this kind of data set will require machine learning. Well, first of all, if it's not numerical data, if it's sort of like audio, visual, pictures, text, audio, then definitely you have to go pretty much on the machine learning route, because traditional statistical methods only applies to numerically captured measurements. Okay, so this is where we are right here, about right here. So today, again, we will basically just give you guys, well, how many of you are there? 40, right? Right? Not cut. How should we do this in terms of time allocation? Last week we had the students, 10 students already, present a little bit. We are going to do a little bit like that, except we're going to go more into details all the way to perhaps formulation. Okay, and I did mention that in real life, this data thing takes a long time because you have to do a lot of cleaning and stuff. In real life, this formulation and method choice is critical, because that basically gives the upper limit of the quality of your analysis. Okay, if your formulation is not right, it's not useful, you can get something very good, like a 99% correct prediction, but it's not adding any value to your application whatsoever. Okay, same thing with method choice. And in real life, the coding and prototyping, even though it seems like a straightforward exercise, translating what you decide to do over here in computer code, in reality, you have to do a lot of, there's a lot of man hours involved in making sure that the code runs properly, and so forth. Right. So today, again, we'll go over the sort of like a phase one and a little bit of perhaps phase two of your project. So you've done a little bit of data preparation, as we can see from your assignment number 5, I believe. Yeah, assignment number 5. So as I did make the comment in the line group, I was pleasantly surprised by some of you who have really done quite a bit of work in terms of preparation and formalizing your thoughts and all that. Okay, so before we go to individual students, let me do this. Let me just go to my notes a little bit. Okay, and let me open up. Okay, I'm just gonna. Right. Okay, let me go over this. Think of this part here as coaching, or sort of like a tutorial session on how you would package, how you would go about delivering the projects. Okay, so what's required? So let's talk about project deliverables. Okay, now I'm going to cover two parts. There's two parts to this. One is the content flow. Okay, content flow in a sense, it's like if you look at the finished product, doesn't matter what the finished product is. It can be a text, it can be an article, it could be a YouTube. It's gonna basically follow this kind of like a four act. It's basically, it's always like this. Okay, and the different composition may change. So it's gonna have a prologue, it's gonna have a problem, it's gonna have a solution, and it's gonna have a postscript. Okay, so prologue is, well, introduction is an example of a prologue. Okay, so prologue, this means something you say before. Okay, pro in this case is before, like prototype, type that came before. So log, dialogue, this has to do with language, sentence, saying, statement, that sort of thing. So what you say before. And postscript, script is like writing, post is after, it's what you write after. So a good example is a paragraph that says the conclusion. Okay, but instead of saying introduction and conclusion, I'm going to use the word prologue because it's more general sense of introduction. What you need to have, okay, in both in terms of your planning a project and in terms of your presentation will follow this structure. Okay, so it's good to have this kind of discipline of asking yourself, what do I want to say in the beginning? What do I want to say in the end? How do I want to present my problem? How do I think about my solution? That sort of thing. So this is a sort of like a template, as if you will, sort of like a mental template of what you want to go through. And again, this is not hard and fast. It's more like a tutorial coaching and how you can keep this as a template if you get stuck, for example. Okay, so let's get going. Well, the first part I say is the prologue. Again, it's the beginning. It's the beginning of your article. It's the beginning of your video presentation. It's the beginning of your project thinking. Okay, it's when you start with. And the way I write down here is that there are two parts. Okay, when I say there are two parts, it means that, it doesn't have to be just two parts, but this is the way I conceptualize. One is more specific, one is more general. Okay, what do I mean by that? Well, specific, okay, would be something that is relevant to what it is you're trying to deliver. Very specific, okay? It's localized, it's specialized, it's the context. So for example, you can, I've looked at some of your assignment number 5. And again, I do like that because it does contain exactly this, the context would be something like, well, we are facing some kind of specific context. In this case, maybe post-COVID, okay? Or having to deliver education via Zoom or something like that, okay? Or some kind of online interaction, teamwork. So this is kind of context. Well, context just gives you a sort of like the picture of where you are operating, where is it located. It's about dealing with say a post-COVID scenario or something like that. And then the motivation is a little bit like context, except it's more about why or what. Okay, a lot of time in a very formal academic paper, this motivation is fairly obvious, right? There's a gap in the understanding, so this paper addresses that gap. Okay, people have studied this, how A links to B, how B links to C, but they haven't studied how A links to C or something like that. Okay, so it's sort of like a gap, knowledge gap is the motivation. In your sense, you may have something a little bit more personal. Okay, and so in this project, it could even get more personal. Okay, I'm reminded of the dog collar, the dog emotional stress thing. Okay, but it's not a personal blog, so you're not going to write something like, well, the other day my mom came and did this, and so I was thinking about it. It's not that personal, but it is a little bit of a personal motivation. You observe that there's some kind of economic ramification of COVID, and so you want to help and so forth. So this is about specific. Now, general in this case is about stepping back and say, where is this all located? And the most important thing, okay, that I insist on is what's called literature survey. Okay, so you're not, out of nowhere coming up with this project. Okay, it's not the first time we are trying to measure emotional health of dogs. Okay, this has, unless you are, completely like a Venus, just full-blown adults out of a shell. Okay, that's not likely to be the case anywhere. Okay, it's not even for my case. So there's going to be a literature survey part that has to do with what have people done, what are people looking at. They're looking at emotions of human with brainwave, or maybe dogs have brainwave, whatever. Okay, and then the general is the other thing is more like about application scope. Where does this all fit in terms of delivering something that helps business, helps humanity, and whatnot? Okay, so this is something that should be sort of like, this is where you get to be more, I guess, imaginative. Okay, this is not this. You're not free to say anything. You do have to cover this sort of thing. Okay, that's what I'm looking for. Okay, now some it's not a 25% this, 25% that, 25%. No, that's not what I'm trying to say. Okay, but these are the things that you should have in your prologue. Now, in a formal writing, this and this usually appears in an introduction. Literature survey usually begins either in the introduction or also part of your methodology. Okay, but anyway, it comes sort of like early on. Now, let me skip all the way to the end. The end is postscript. The postscript is sort of like encapsulating, so like summarizing. So the summarizing is what's done here, achieved herewith, right? So this is basically the summary part. So in conclusion, what we did was this, blah, blah, blah. What we found was that, blah, blah, blah. But more importantly, because you hope that your work is not a dead end, okay? You hope that your work is not a dead end. You hope that your work will appear in somebody's literature survey, right? Then you should indicate the future work. Like, we have done this, we have tweaked the technique, but we haven't explored something, okay? And that's subject of future work. Now, this could mean that later on you do the future work. It could also mean somebody looks at your paper or looks at your work, reference it in the literature survey, and then carry on the research. Okay. Now, at this point, let me just mention one thing which I think is what plagued the Thai society in terms of progress. We have, let's, at the risk of overgeneralizing, okay? Let's say Thai people fall into two classes: active people, hardworking, and lazy people. Okay, lazy people don't want to do anything. They just want to take somebody else's work and use it. Okay, hardworking people want to invent new things. Okay, well, I assume you guys are hardworking, part of the population. That's why you're in the school of innovation. Problem with, I say Thai society, but you could say it to any society, I think, is that the second group, the hardworking group, people who want to invent things, who want to make a difference, make an impact to society, they tend to, what's the word? They tend to try to think that, they're the first one thinking of the problem. So in other words, they don't build on what's there. Okay, so I think this is very important. Okay, there are lazy people who want to use other people's work, and there are hardworking people who want to invent everything new or come up with something new, or just, this is my own brand, this is my invention. Well, progress doesn't work like that. Okay, progress in a generation may work like that. Like you can say, okay, I created something and I try to sell it and it looks good and blah blah blah. But in terms of humanity's progress, okay, the way it works is that, yes, you create new things, but you build it on top of the good thing that's already there. So you're not using existing people's work because you're lazy, right? You're hardworking. Okay, you're not copying homework, but you're taking something that is already good as a foundation and build on it. And this is something I really want to instill in you guys, okay? Because in my professional life, I only see two types of people: lazy people who want to just use other people's work, and active, ambitious, hardworking people who want to make everything their own invention or their own brand. And so previous people's work gets ignored. This happens all the time when the organization changes the CEO. The new CEO comes in and just, rebrand everything. Okay, because you have this idea that you want to be an innovator. This move in the corporate happens under the leadership of this CEO. Okay, no CEO comes in with the intention of taking what's already good and making it better, because it's not their creation, it's not their baby. Okay, so this is very important. Okay, so think of society progress as an elephant herds in Africa. Okay, in Africa, elephant mothers don't just raise their baby, they raise other elephants' baby as well. Okay, so this is the health of the community. Okay, so try to be that. Try to be hardworking, but acknowledge what's there, what's in what people have done, and build on it. Okay, and that's why I put a lot of emphasis on this thing. It's the discipline of literature survey. It's the recognition that something that's already done is good. You can improve. Okay, so don't think that you are first in the world to think of, say, I give the example again, measuring dogs' emotion. Okay, so try to be that. Okay, so that's the beginning and that's the end. Now the big chunk is the middle part. So the first part is the problem. Okay? The problem essentially comes down to two things. It's what you want to do, given what. Given what in this case is not in terms of technique, but given the data. Okay, so we can think of it this way. We can think of technique as public domain, even though you can actually improve on the technique. You tend to think of something like it's already out there. How to do regression, how to do machine learning, how to do all this. But people haven't focused on a particular set of data. So you think of data as a resource. Okay, whereas methodology, you think of it as, well, it's out there. Okay, it's out there. Yes, you have to, in some case, buy the software. In some case, you have to write it yourself. But in a way, it's not like a scarce resource. You know, in our line of work, we think of data as the thing that really determines. You know, if there's information contained in the data set, yeah, we can crack it. Okay, if the data is no good, no matter how how God-like your machine learning algorithm is, it's not going to do anything. So it's the rubbish in, rubbish out kind of thing. So what do you want to do with what? Okay, what do you want to do? Now, let me show you what you want to do. What do you want to do separate into, in this case, I'm just making 4 categories. Now, this is not to say that they are mutually exclusive, but you have to ask yourself. So these are all, this template is something that you can use as a checklist, you know, what exactly you are adding value to. If you're adding scientific value, that means you're discovering or uncovering something. It could be insight, it could be knowledge, it could be something. It's about uncovering some insight. Engineering is about operationalizing that insight. Okay, so you can create a tool. For example, you can say, well, the scientific breakthrough in machine learning is already there, but I want to make it into a robust tool for analyzing visual data. Okay, now this stops short of what I call practical, because when I mention practical objective, that means you actually have a specific thing you want to solve. Okay, so scientific could be something like how a machine learns, how a machine represents audio visual data as numerical vector. Engineering would be like, well, the training algorithm that's needed to make that possible. Practical would be, okay, somebody's done the scientific work, somebody else has done the engineering work. I want to use it to predict dogs' emotion. Okay. And pedagogical, well, that just means about education. Pedagogical is about education. So this is about advancing the state of knowledge or educational tools. I would suspect most of you guys are kind of around here. Okay, but do ask yourself that. Do ask yourself that. Okay, so again, trying to predict the dog's emotion is a practical thing. But answering whether or not dogs have emotion that can be captured by skin contact or brainwave, that's a scientific thing, right? So it's not one thing or the other. Data. Now, data, you have to cover this in your part, in your delivery, okay? Origination. Origination doesn't mean where does the data come from. It means how is the data originated. In other words, if you're talking about, say, heart rate measurement, the origination is the process of generating the heart rate measurement, right? The source is where you get it. So you can get it because you actually take the heart rate measurement from your own chest, or you can get heart rate data from Kaggle, or you get heart rate data from Mathematica example, okay? And then how do you access it? What kind of scope? And then very important thing, meta description. Meta description is like a top level description. Like you have how many dimensions, how big is the data set, is it incomplete, is it time series, does it cover this period, does it cover that period? It's sort of like description about the data, okay? Is it categorical data? Is it mostly categorical data, or is it ordinal? Within the categorical, is it ordinal or nominal scale? Okay, if it's numerical, does it actually have absolute zero? You can define a ratio scale, or is it more like interval data? Okay, so meta description. So you have to sort of like describe. So what you want to do with what now, and then your solution. That's what you deliver. Okay, after convincing the audience or the client target, this is what you do. It's gonna be important. It's good. It's important. It's nice, and we can do it. People have done it, but they haven't done this step, and we're gonna fill in that step. Well, this is your doing. Okay, and that's basically 2 parts. one is the methodology, it's the technical part. The result is in a scientific paper, that's usually called the experimentation. So if you have the data and you have the analysis, you run the analysis on the data, right? Or if you are, I'll give you an analogy, in a biological experiment, instead of data, you have population of lab rats, okay? Your methodology is some kind of medicine or whatever that you inject into the rats, and the result would be what happens to the rat. Does it get stronger, bigger, or does it die or something like that, or do they die? Okay, so I want to do this with that, but I use this, I feed data into the methodology, and I get some result. Now, in terms of methodology, again, ask yourself, where do you fit in? You're using old methodology. That means something that I expect most of you would be using like so Mathematica's built-in classifier, using Python scikit-learn library, using Thai NLP library. So the methodology is there. You have to reference it. So methodology could be there, just exactly as is. Okay, exactly as is. It's like using the tools. Okay, or you can improve it. Okay, for example, my paper that has to do with the decision tree analysis on the breast cancer data is about improving. So you improve the standard decision tree with something else. Okay, in this case, fuzzy classification, fuzzy conviction score, and something like that. So that's my contribution. Or you can, in rare occasion, come up with something completely new or mostly new. Okay, that can happen as well. Okay. The result then, this is also ties in with your objective, right? What's your result? Your result is insights, and that's a lot of scientific paper, okay? I want to find the relationship between A and C, because people knew about A and B and C, they don't know about A and C. Okay, fine, study, I find the insight. Techniques is sort of like wrapping the tools, the data into, okay, for this kind of data, you have to clean this way, you have to use a neural network, you have to partition data, and blah, blah, blah. Now, techniques are something that's more descriptive of well, it could be technical in terms of, mathematical description, but it's descriptive in the sense that it's giving you how to. Whereas tools would be something like, hey, I just created a software. Not only can you follow it here, you can actually download it from cloud. Okay, so more and more, I would say that, say, 50 years ago, most scientific paper would just deliver this. Okay, however A is related to B, nobody knows. Okay, but just know that they use this technique, this regression, and they find this relationship, and that's the insight that's delivered. Later on, you start having techniques. So you have paper that includes pseudocode, right? To do this algorithm, you have to import the data, run this loop, run that loop, blah, blah, blah. And finally, you have something called paper with codes. That's when you deliver not just the paper and the result, but you literally deliver the codes, okay? So let me go to that. Paper with codes. And this is the, well, I hate to say it's a fashion, but it's a trend today. You don't just publish this, okay? This is what your finding is. You go to paper, and that would be like a text paper, but you can also go to code. Okay, so let's go to paper. And if you go to paper, see, you click on PDF, you get abstract and blah, blah, blah. If you go to code, you literally have the computer code. Okay, and this is good. It's good because it actually helps your peer replicate your data. This is what I want your project to do. Okay, so your project should be in similar vein. I'll talk about what I expect. Okay. Now, let's talk about. So this is 1, 2, 3, 4. This is sort of like 1, 2, 3, 4. Is what I will be expecting from your project. I will be expecting the prologue section. I'll be expecting the problem discussion, the solution, okay, and the postscript. So I expect this, okay? And you have to ask yourself, again, this is not about having your methodology has to be new. No, it could be old, it could be improved. Just have to ask yourself, where does it fit in? Okay? And don't claim beyond your delivery. That's important. Okay, say, oh, this is something new because you didn't do good enough literature survey, and then somebody realized that 5 years ago somebody already did exactly that. That's quite embarrassing, and that happens. Okay, now in terms of deliverable, in terms of format, okay, of course traditionally you have text document. Now text document range from anything like Mimeo. Mimeo is like a note for yourself, right? So you can use it as a base for your study later. You can extend the project. This is something that you start producing right away to your graduate students. White paper is a little bit like this, except it does have commercial value in the sense that if you're selling a software and the software is based on the study that you did internally, you can write that up as a white paper. It's called white paper or technical paper, okay? White paper, anybody can write, anybody can publish. Nobody has to review. Now, the next two steps up are conference paper and journal article. These are something that you have to submit and people have to see how good it is. So it goes through a little bit of editorial, okay? So conference paper, the conference editor will look at it and see if it's any good. If it's not good, it gets rejected. So this can be rejected. White paper cannot be rejected because you write it, okay? Anybody can write it, okay? So conference paper can be rejected by the conference organizer, but it's not as rigorous as journal. Journal is like something, it's the final arbitration. It's saying, supposedly the journal editor has peer reviewed it, see it's good enough, okay? And another thing that you hear the word is peer review. Okay? Why is it called peer review? Well, it used to be all peer review, okay? But later on, the publication gets so big that some journals just start publishing without reviewing, okay? So to qualify the quality of the research, they add the word peer review. It used to be anything gets published has to be peer review. But now you have journals that gets paid. You can literally, you can print anything you write, like a white paper, and you can go to some journal and pay them, and they'll publish it, okay? And you get a journal article, and just because you have the money, and that's completely nonsense. And there's been a big scandal on academics. I think a few years ago, it was a big thing in Malaysia where a lot of university researchers were, beefing up their CV with publication at paid journals, okay? So I don't expect here. So you will be writing along the line of white paper, okay? White paper. So it's sort of like a technical paper of your thing. Now, so that would be the paper bit, okay? Now, the tools here that comes in the form of computer program, again, if it's something like, to do this, you have to take this data, scale it, run it to this, and that's a kind of pseudo code. If you give actual codes, okay, that would be, so from here, when you go to paper with codes, usually that's what it means, okay? When you go to codes, they'll go to some kind of, archive. Where's the method? Oh, codes, yeah, something like that. And when you go to here, there'll be some kind of codes in here somewhere, okay? So scikit learn code. So you have to go, you have to dig through a little bit. But eventually, I think you get some kind of Python code, okay? So you get this kind of Python codes, okay? This is very nice. It actually tells you how to install it, okay? Nowadays, there's not so much distinction between codes and executable. In the old days, you write a program and then you compile it into executable and it becomes a digital code you can't read. Nowadays, when you work with Python, you have a text code that human can read and edit. So when you run the Python script, it becomes an executable right away. So there's not much distinction nowadays between these two. okay? And then finally, you have this thing called software. That means you literally have like quote unquote professional tools, reading the file, reconfiguration, but it's almost something you're ready to sell or sell to the market, to the app store or something like that, okay? And finally, nowadays, we have this option of audio, visual, multimedia. Now, in the old days, you write a paper, you go to conference, and you prepare a set of slides, okay, like PowerPoint. Okay. Nowadays, you can prepare infographic, you can prepare mind map, you can pre-annotate your slides, right? For example, you can go to Loom. I think there's an application, or even in Zoom, you can literally go slide one by one and just annotate and just play it. Okay. And you can go all the way to, you know, using AR interactives. I don't imagine you go that far. Now, so this is sort of like in general, okay? This is how you can use this for the rest of your life, okay? Whatever project you have, whether or not it's for your own self, for some user in your company, or as a data science consultant to your clients, okay? So you're gonna have this and this. Now, for this class project, okay? I did you know, tell you a little bit already what I expect, some kind of paper. So at the minimum, it's paper plus video, right? I didn't say that. Another thing I should like you to add is to make yourself aware of where you fit in. So I have this, if you recall early on, this kind of mind map, right? Of statistical method, machine learning, and data analysis, right? So this thing is going to branch into different techniques, different names, and so forth. What I want you to do is take this, right? Take this, identify what track you're following. So if your project takes you to, say, supervised learning, I'll give you an example, okay? So this is going to branch out, you know, 100 different ways. So if this technique, say, you don't use statistical method to do this, okay, maybe you do. So you go a little bit, but let's say you go to, say, neural learning, and you use some kind of classification analysis, okay, let's say you use decision tree and random forest. You would do this, okay? And just put something like that, okay? Or you can write something more if you like. But basically, to identify this is where your project sits, okay? So maybe your project will be more focused on supervised analysis, so it just has that. Or maybe you use a combination of supervised and unsupervised learning. So I'll give you something that's you know, more comprehensive later, like you know, learning. So you do some kind of dimensionally reduction, okay? Now, if you happen to find some other technique that is not in here, by all means, you can add. You can even invent your own, right? Remember, you can improve on the technique. But I'm just writing the basic standards, right? Principal component analysis. Let's say you use that in your thing. Just write it. Okay. And then you submit this expanding tree. Again, you can print it, export as a picture. Okay. So I expect to see some kind of diagram a little bit like this. Okay. If you have one thing here, and another thing here, another thing there, you can submit maybe 4 pictures, so it doesn't look all, you know, zoom out. Okay. So maybe you do one here, and then do another one for statistical method, another one for the sort of data. So this is, you know, what kind of data are you working on? Are you working on, say, for example, nominal data, ordinal data, scale, or both, right? You can use both. It's fine. You can use both. Okay, so your project use both, right? Fine. Okay, it doesn't use numerical method. Fine, don't use that. It use you ask super. Okay, so I want this to be also part of your delivery. Okay, I expect that most of you would have similar kind of branching. Okay, but this is to be cognizant of what it is you are doing, what you are delivering. Okay. So again, you can add more comments. Okay, you can say something like, use this just for initial exploration, but not the major focus. You can whatever, you can qualify that. So this is sort of like an orientation. Okay, so this is essentially, if you think about it, it's a visual way of representing literature survey. If you think of this spanning out as some sort of like a knowledge, state of knowledge in terms of data analytics, you can say, okay, well, it's everywhere, but I'm not using everything. Okay, I'm not using dimensionality reduction, or I'm not using TSNE, but I'm using PCA. So paper, plus I would say annotated mind map. So these are the three things. Okay, and of course you use them together, right? You can put annotated mind map in the paper. You can reference, talk about it in your video. So I put this in a bracket. Okay, so this can be packaged. So I don't want just isolate. Now, when you submit, and here's very important. Some of the data is from external source. But if you have downloaded, or the data set is not that big, your TA has to be able to run the program. So in other words, you should zip everything in one folder. Or everything in one folder. Okay, so this is going to have data. If say something like, I'm going to figure out how to make this uniform. Okay, remember your assignment 4 was something like assignment, and then your ID or something like that. So we might do something like that. Okay, like a project data ID number. Okay, .csv. Okay, and then you have something like project ID. Okay. ND. So presumably, once this, when we grade your project, okay, also video, right? Something like that. Okay. Now we can just open this, run it. Presumably, this will take this. If you do the set directory, it's just going to pull this thing up and run it. It should get the result that you show. Again, the paper will have screen capture and whatnot, but this code should be like this. Okay. Now, in real life, your paper, you can submit it to paper with code, and this would be one thing, and this would be the code. So this is already like paper with code. Okay. Now, except in this case, you also add data, add video, add everything else. Add that mind map as well. Okay, so this is how you should deliver. Everything will be in one zip file. Okay, everything will be one zip file, and make it uniform. So your TA or I will just download everybody's zip file and then look unwrap it, and you have that. So everybody will be in there. Okay, this is sort of thing. Now, in real life, you may not have video. You probably would not have a separate mind map. Okay, but certainly you have the paper. Okay, and nowadays it's usually paper with code. Okay, so follow this paper with code as an example. Okay, paper with code. Okay, and I show you example of the one that your TA did, right? Let's see. Okay, so once you see that, you go click here. It's a paper. When I click on PDF, it goes to my own archive. That's my internet archive for academic paper. But when you click on the code, it actually doesn't go to mine. It goes to your TA's GitHub page. Your TA has his own GitHub that he shares the code. There's a lot more that he can share, but a lot of the work that we do is proprietary, so he can't show much. But this one, he can. Okay. Now, would it be nice if you did something really interesting that you can maybe submit to a paper with code, and they would you would add to the knowledge? That'd be nice, but you know, I'm not making that requirement. Okay, but certainly feel free to do that. It's very good. Okay, it's very good. It's a way of getting from the community and giving back, because you share everything. Okay, nobody is independently smart or intelligent. Okay, so that's the thing. Okay, so. GIF or whatever, video, whatever. Okay, right. So that's basically what I want to say. That's all I want to say today. I'm going to go ahead and well, we might as well stop the video when we come back and then restart the video, so that the next 2 hours is all about taking individual project and discussing it. ดีไหมนะตัดวิดีโอตรงนี้จะได้
Can about the submission?
Yeah, what? Sorry?
Okay. So can I ask when is the day we did it?
Should be here, right?
Okay.
Kind of in mid-November. Again, this is wrong. This is not 16. This is 23rd. Right?
Okay.
If you think about it, the project presentation session, okay, you would start by playing your video, okay, and that I kind of forgot what kind of limit we have. Shouldn't be that long, okay. Short video is good, okay, and then your friend will, you know, interactively ask questions, okay. So this is probably maybe the last chance to get like a participation score if you ask your friend a lot of questions. Okay, so I expect a lot of discussion, friendly discussion. Be nice to your friend. Okay, but should be here. I might in order to train you guys to do a more elaborate presentation or more interactivities, I might try to squeeze all this in so that we'll have 2 periods of project presentation. But for now, let's just keep it at 1 session. Okay? So obviously you have to send it like day or 2 before that. Okay?